What if I told you that General Motors isn't just trying to build electric cars anymore? They're trying to power the future of artificial intelligence. And the craziest part? The batteries that could keep tomorrow's AI data centers running might not come from Tesla, Nvidia, or even a utility company. They might come from a car manufacturer. GM has just revealed a major new strategy involving sodium-ion batteries, recycled EV batteries, AI data centers, and a partnership that could completely reshape how the world powers artificial intelligence. And honestly, this might be one of the most important tech stories nobody is talking about. Let's explain. First, we need to talk about a problem that's getting bigger every day. AI is hungry. Not metaphorically, literally. Every time someone generates an image, asks ChatGPT a question, creates a video with AI, or trains a new model, massive data centers have to perform trillions of calculations. Those calculations require enormous amounts of electricity. Companies like Microsoft, Google, Amazon, Meta, and OpenAI are racing to build more data centers, but they're all running into the same issue. Where do you get enough power? Some estimates suggest future AI infrastructure could consume electricity on a scale we've never seen before. In fact, power has become such a critical resource that technology companies are now competing for energy supplies just as aggressively as they compete for AI talent. And that's where things start getting weird, because now car companies want in. Traditionally, automakers built cars. Simple. But electric vehicles changed everything. To build EVs, companies had to become battery experts. And once you're making millions of batteries, you start realizing those batteries can do a lot more than sit inside vehicles. Last year, battery recycling company Redwood Materials began using retired EV battery packs to help power AI data centers. Ford announced plans to produce batteries for the electrical grid. And now, GM has made what could be its biggest move yet. Instead of simply building batteries for cars, GM wants to build batteries for the future electric grid itself. And they have a very interesting weapon: sodium. Yes, the same element found in table salt. Although, please don't go stuffing your salt shaker into your Tesla. That's not how science works. Most modern EV batteries use lithium-ion technology. Lithium batteries are powerful and energy-dense, but they also have problems. Lithium is expensive, supply chains can be complicated, and under certain conditions, lithium batteries can overheat. GM believes sodium-ion batteries could solve many of those issues. Instead of relying on lithium, these batteries use sodium, one of the most abundant elements on Earth. That makes them potentially cheaper, potentially safer, and potentially longer lasting. Sounds amazing, right? Well, there is a catch. Actually, a pretty big one. Sodium-ion batteries are heavier and bulkier than lithium batteries. For a vehicle, that's bad news. Nobody wants an electric truck weighing as much as a small moon. But for giant energy storage facilities sitting next to a data center, weight doesn't matter. The battery isn't going anywhere. This is exactly why GM believes sodium-ion batteries are perfect for AI infrastructure and grid-scale energy storage.
To make this happen, GM is partnering with a startup called Peak Energy. Together, they're developing an entirely new sodium-ion battery chemistry specifically designed for large-scale energy storage systems. And here's where things get interesting. Because sodium batteries are less prone to overheating, Peak Energy has been able to eliminate some expensive hardware that traditional battery systems require. No complicated cooling systems, no massive fire suppression systems, fewer moving parts, lower maintenance, lower costs. Peak Energy's philosophy is basically the best part is no part. which sounds like something a minimalist engineer would put on a motivational poster. But from an engineering perspective, it makes sense. If a component isn't needed, removing it eliminates both cost and potential failure points.
Now, before you run out and invest your life savings into sodium batteries, there's one important detail. These batteries aren't ready yet. GM says trial production won't begin until 2028. Commercial deployment will come later, so this is a long-term strategy. But GM isn't waiting around. In the meantime, the company plans to supply lithium iron phosphate batteries, also known as LFP batteries, for energy storage systems. LFP batteries are already widely used because they're cheaper and safer than many traditional lithium-ion designs. Think of LFP as the bridge technology, while sodium-ion development continues.
But that's only half the story. The other half involves old EV batteries, and this might be even cooler. Most people assume an EV battery reaches the end of its life and gets thrown away. Not exactly. A battery that no longer performs well enough for a vehicle can still store huge amounts of energy. That's where Redwood Materials enters the picture. Founded by former Tesla executive J.B. Straubel, Redwood has become one of the leaders in battery recycling and reuse. The company already operates a massive microgrid using second-life EV batteries at an AI data center in Nevada. Instead of sending those batteries to a recycling facility immediately, Redwood gives them a second career. Kind of like battery retirement. Only instead of playing golf in Florida, they're helping power AI servers.
GM currently has around 10,000 used battery packs flowing into Redwood's system. And now GM is buying a large battery installation from Redwood for one of its Michigan factories. The company estimates the project could save roughly $3 million over its lifetime. That's not pocket change. More importantly, it provides backup power and improves reliability. Factories hate downtime. Every minute of lost production costs money. So if batteries can prevent outages while lowering electricity costs, the economics become very attractive. GM says this could eventually expand to many of its manufacturing facilities. And honestly, it's hard to argue with the math.
At first glance, this story sounds like it's about batteries, but it's actually about something much bigger. It's about the convergence of three massive industries: artificial intelligence, energy infrastructure, and electric vehicles. AI needs power. The grid needs energy storage. EV companies have battery expertise. Those three trends are now colliding. The companies that solve the energy problem may end up becoming just as important as the companies building the AI itself. For years, we assumed the biggest technology race was about chips. Now, it might be about electricity. Because the smartest AI in the world is useless if you can't keep the lights on.
So, what do you think? Could sodium-ion batteries become the future of AI data centers? Will recycled EV batteries give old electric vehicles a second life powering artificial intelligence? Or is lithium still going to dominate for decades to come? Let me know down in the comments. And if you enjoyed this breakdown of the future of AI, batteries, and energy technology, make sure to hit that like button, subscribe, and turn on notifications. Because the next big tech revolution might not happen inside a computer. It might happen inside a battery. Thanks for watching, and I'll see you in the next one.